Here goes 0.
Linear algebra is really good. And then there's abstract algebra.
Oh man.
You guys haven't even
Abstract
touched the freaking stuff yet.
Oh,
Still baby steps. All right.
man.
I never even took there's topology and cryptography. I have a graph or something. All right. Let's talk polar graphing. Okay, so we're going to do one problem today. We're going to do this one graph together. Okay? So on your little graph patch, just put example 1. I don't think it's number 1 or example. Okay?
Does it matter?
It doesn't matter, pick one. Okay? Actually, this is number 1. It is an example 1. It's number 1. This is number 1 for your number.
Oh, yes.
Alright, and then you'll do the other 5 on your own. Okay? Alright, I'm going to go back. Okay, and get that equation written down. Okay? So the idea here is we're going to plot points. That's how we're going to graph this thing in. Okay, so it's not exactly the shortest thing in the world, but you are eventually probably going to be able to pick up a pattern. Okay? And if you start learning your equations and which ones are which, you'll probably pick up the pattern faster. Okay? We're just going to assume we don't understand the equations yet and start graphing. Okay? Alright, so I'm going to put it, I put all the radian measures in the little t-chart. Okay? And then we're going to plug into that equation right there. Okay? So, what is the cosine of 0? 1. Okay, so 1 times 2 is 2 plus 2 is 4. So I can go ahead and plot that point. 0 radians out, so I'm on the 0 radian move. And how many rings out am I going to count? Okay, we're going to do this a little bit differently. I'm not going to just count 4 because it would be really tiny. Let's go every other ring. Okay, so it's going to be scaled by 2. So that's going to be 1 out, 2 out, 3 out, 4. You know what would be a really good idea? Is go ahead and trace over the ones we're going to use. Does that make sense?
Yeah.
That makes it a little bit more obvious which ones we're actually going to. I'll do it in this red here, and then I'll switch to a different color. Because at some point they all come together. Okay, so there's my 4 circles. Alright, so I'm supposed to draw a dot right there. Okay. I may need more than 4, I don't know, but we're gonna start with 4. Okay. Alright. Pi over 6. Okay, so I'm gonna pick what's the cosine of pi over 6.
It's
I got 0. This is the 1, that's the square root of 3, right?
Yeah.
So it's square root of 3 over 2. Okay, so I know that this is something like 2 plus 2 square root of 3 over 2. Okay, these do cancel, you're right.
Yeah, 2 plus 4.
Okay, so it's 2 plus square root of 3, that's a little bit better, right? Okay, we can estimate that better, because guess what? This is on the non-calculator. Okay, so you don't have your calculator to help you estimate. So let's think about what about that is, right? This is just counting the number of rings. So I know I've got to go 2 rings, but not quite. This is probably like 1 point something, right? So maybe 3 rings out, okay? But not 4 yet. So a little bit beyond 3. So I'm going to go to my radian measure of pi over 6. I'm going to go a little bit beyond 3. As I estimate, okay? We know what square root of 4 is 2, isn't it? So this has to be 1 point. All right, pi over 4. So what is the cosine of pi over 4? Square root of 2 over 2. Oh, it's 2 times. Sorry, I lost my 2. So 2 times. So I really got 2 plus square root of 2. Which one's going to be bigger, square root of 3 or square root of 2? Square root of 2, so I should go in a little bit, right? It's going to still be a little bit bigger than 3, probably, but it's gonna be closer in. Alright, what's the cosine of pi over 3? 1/2, so that one is at what? 3, right? That was exactly at 3. You can kind of see that it looks like we're making a curve that's starting to go inwards. Okay. Alright, there is a spiral. We didn't see the spiral. But there is a spiral. All the ones we saw before. Alright, pi over 2 is cosine of pi over 2. Ow. 1 of 0.1. Okay. So what is...
No, it's 0. It's 0.
It's 0.
Yeah,
Right. Alright, so what is my value for 2 plus 0? 2. So I'm going to be out 2 rings on pi over 2. Alright, 2 pi over 3, let's see, so this is now coming down 1, right? So negative 1/2. So I got 2 plus 2 times negative 1/2 is going to be what? 1. Okay. So at that 1, it's out. Yes. It's going to be that. Okay, and again, it looks like we're still kind of coming in. Okay. All right, 3 pi over 4. Okay, so we need the cosine of 3 pi over 4. Negative square root of 2, so I got 2 plus 2 times negative square root of 2 over 2. These are going to cancel. All right, so now I've got 2 minus 1 point something, right? So am I going to be bigger than 1 or less than 1? I'm going to be somewhere less than 1, right? So I'm going to probably come in just on that one, come in just a little bit more. So again, I'm going to estimate. I know, aren't you glad we did it every other ring?
Yeah.
If not, we wouldn't be able to see it right now. And again, it starts blurring. Okay? We could have probably done every third ring. Okay? Alright, 5 pi over 6. What's the cosine of 5 pi over 6? Negative square root of 3 over 2. And again, that's going to bring it in further than the square root of 2, right? So I'm going to get even closer in. It's hard to see the line that it's on. You almost can't see it, right? Alright, we're new pi. Okay, so I think my dot is this. Okay, the pi. So cosine of pi is what?
0.
It's negative 1, 0.
It would be 0.
So what is 2 minus 2?
So it'd be 1.
0. Okay, so I'm going to come in here at so I've been all the way into the origin. Okay, now we're probably going to start establishing a pattern. We're about halfway. Okay. All right, 7 pi over 6, so that's the one, that's got to be the square root of 3, right? So, and they're both negative this time. What's the cosine of 7 pi over 6? Negative square root of 3 over 2, so isn't it going to be 2 negative minus square root of 3? It's going to pop out just a bit. And again, that's going to be tough to see. Okay. It's going to end up here, yeah. Okay. So let's go one more and make sure the pattern exists, right? Because isn't that one the same as this one? Okay. Let's see if the next one comes out, and then we can kind of follow the pattern. Okay. All right. So 5 pi over 4. What's the cosine of 5 pi over 4? Negative square root of 2 over 2, right? So those are going to cancel. This should have been a plus sign. So we got the 2 minus square root of 2 again. So again, I got 2 minus 1 point something. So I'm at 5 pi over 4. And I'm a little bit further out. Okay? Alright, so are we pretty confident that there's probably a pattern established? But I'm probably just going to repeat all these values going in the other direction. So I'm going to have 1, 2, 3, 2 plus square root of 2, 2 plus square root of 3, and 4. And that makes sense that it goes back to 4 0 should be the same number, right? Okay, so now we're gonna have to plot those points, and either you're gonna try to plot the mirror image, right? And it's not always the mirror image. You have to wait until you establish a pattern. Okay, so it's not always. You gotta know which one you kind of start with. Okay. And then, or you just go ahead and plot. So I'm gonna go 4 pi over 3, and I'm gonna go out 1. Okay. And then I'm gonna go 3 pi over 2, and I'm gonna go out 2 rings. 5 pi over 3, and I get to go out 3 rings. And then basically between these two here, I need to just go a little further out and a little further out, right? So a little further out, and then probably a little further out. And then it would return back to its original point, right? So I'm gonna go ahead and connect the dots. And it comes in like to the center and back out. It kind of looks like a heart, kind of a blue heart shape. Okay. All right. Mine is not very. I should have had it more curvy right here, right? All right. So the goal today is you're going to you're gonna practice graphics. You only have to do 5 more. Okay. All right. Here's the next thing I want you to do. Let's pull out. You should have the sheet you worked on yesterday in front of you. Okay. We're gonna do some labeling. Yes. Alright, the next thing I need to do is open to page 735. Okay, so find page 735. Okay, what? Okay. So, everybody on page 735. Okay. So there is kind of a key of all the different types. On the next test, you're going to have to be able to identify the different types. You're going to have to match an equation to the graph. You're going to have to match an equation to the name of the type. Okay? So, you're going to end it. So you'll get there. Okay, so this was the first set, wasn't it?
Yeah.
Is that right? Okay. So what kind of a shape? Look at the graphs on page 735. What's the name of that shape that we made there? It's a circle. It's not the same. Look at the picture and look at the thing on the page. It's not the first row. Okay? So remember how I said there was a blank line?
Yeah.
Now fill in the name on the blank line. Circle. Okay? On the paper. Okay? The paper from yesterday, you know it's a circle. Okay? Okay. Alright, so the first one's a circle. What do you notice about, so you notice it has it, and you might want to also write out, because this is kind of your notes on this. The equation is r equals a cosine theta, or r equals a sine theta, in general, right? So notice there's nothing being multiplied by the theta, the coefficient is always in front. That's what makes it a circle, okay? What kind of generalization, you kind of looked at all of them, and I know you kind of looked at all of them at the end of the lesson yesterday, could you make about the cosine versus the sine? Cosine is kind of on the symmetric about the x-axis, right? And sine is symmetric about the... Okay, let's find somewhere on that paper to make sure you have that written down. So cosine is symmetric. This is kind of a generalization, but you can symmetric on y, no, what is it, x, right? X-axis. Sine is symmetric on the y-axis. Okay. It's about symmetry, right? Okay, let's look at the next set of curves. Alright. So I bet you didn't know the infinity symbol actually has another name, right? It's the lemniscate. Lemniscate. And there's some kind of weird, like, that isn't even, there's another letter that they sometimes put in there that has some kind of weird marking on it. If you actually look it up online, you can hit the little button that tells you how to pronounce it. Okay? Alright. And notice, those ones look a little different than what they are here, so go ahead and write the name of the flank so you know it. So, okay. And then probably what you want to do is write the two equations. It's always the one that has the r squared in it. Are all the equations on there for you? Okay, that was good. And they're in generically on there for you? Okay, good. Awesome. Even better. Okay. So, again, the same kind of you don't have to write down the sine and cosine thing again, right? Cosine's still symmetric about the y or the x-axis. This one is the one that doesn't kind of match. That's the only one that's not going to fit in. Okay? That generalization. Okay? Alright, let's look at the next one. Alright, what are those ones called? Rose curves. Those are the pretty ones, right? Okay, now, look out in the left. So before you actually, what do you notice about let's see. Oh, this value in here. What do you notice about that value in there on those two? It's odd. And it's what? There's that many petals. So if it's odd, there are that many petals, right? So the way we're going to write that down is n petals if n is odd. Okay, I would write that down so you know it. If n is odd, so if n petals, if n is odd, they're called petals because it's a flower, right? Even though it looks more like a daisy than rose. Sorry, guys. Okay, now look at this number here. Is it the number of petals? It's double the number of petals. Okay, so it's 2n petals. Okay, if n is even. Okay, so that's how you figure it out. You look at n is even, you see 2n petals. Right? It's okay. Right? Today we're trying to make sure we have it down the right way. Okay? Alright. Okay, we good with that rose curves? Alright. So the next few kind of belong all to the limacone family. Okay. Limacone. Okay. What specifically which ones are these? Limacone of interlude is what you're going to write on this one. Maybe this is the one with the funny symbol. See the funny symbol under the C? Interlude. If you added the 1 and the 2 together, you didn't do it right. Alright, so, again, what do you notice about the cosines? They're symmetric, okay, and then the sines are symmetric to the y, okay? And then on this I looked down and I grabbed the wrong picture. Okay? So AB is if AB is less than 1, remember the A is the first number, the B is the second number, right? So that's what creates the line of common inner loop. Alright. Next one. What's that one called? Cardioid. It looks like a heart. So cardiac is heart, right?
Yeah, but yeah, congrats.
Alright, so cardioid. Okay. Alright. And this one you want to highlight A over B is exactly equal to 1. Okay. Alright, 2 more sets, right? Okay, and that one right there, what's that one called? Dimpled Limagon. Dimpled Limagon. Alright, and that one, the big important thing to highlight is that A over B has to be between 1 and 2. Okay? Alright. Last one. Okay. What's this one called? And it's really hard to see, isn't it?
Yeah.
But it looks like a circle that's slightly squished. Right? Yeah, it's not quite one side kind of looks less round than the other. Okay? So this is a convex Limagon. And then this is where A over B is greater than or equal to 2. Okay? Okay, so we've looked at that part today. So that, I don't know. I never tell them what to say. Yeah. We look at the equation, but those are like way less circular. So these. If you compare the two, like if you saw 2 graphs that next to each other, you'd be able to say okay. Sorry.
Yeah.
Okay, so here's what you're gonna do the rest of the period. Okay? If you look in haiku, I put up the the homework, and it's got 5 more that you have to do. We did number 1 together, remember? Okay. So you got 5 more graphs that you have to do. Alright? And then so we've gone through this part. Tomorrow we're gonna kind of put this part with we're trying to try some matching with this, and then also matching the names to the equations. Okay, and then we're probably gonna I may go one more day and finish 10-4, and then we're gonna be ready for a test. Okay. So we want to split this into 2 tests. So we have 2 test grades for it, not 1. Okay.
Well, that's what.